All right, so today we are going to cover probability. All right, so best way to explain it is by examples, and then also try and give you an understanding of how we actually use probabilities, and actually also to have a better understanding of it. So I'm going to share my screen first. And if you can't see it, just let me know. I'm now sharing it. It should kick in a second. I'm going to bring a whiteboard up with a table here. And on the rows, you'll see directors, managers, junior. On the columns, you'll see mining, finance, and then total. If you can't see it, just give me a heads up. Okay, Gunadi, I think you have your mic unmuted. I'm not sure if you want to say anything, but yeah, if you're not, then maybe just put it on mute. Yeah, fantastic. All right, so here's the whiteboard. Okay, so before we look at this table and data, let's try and understand what a probability is. Okay, now I think everyone understands, the flip of a coin. A coin can either have heads or tails. All right, now since one side of the coin has a head and the other side has a tail, let's assume this coin is fair. When I say fair, there is no imbalance or sort of physics that have altered the regular properties of coin, right? So if you flip it, you should have a 1 in 2 chance of getting ahead, or in other words, the chance of getting ahead is 1 over 2, all right, or in other words, 50%. And the same applies for a tail. Okay, the probability of getting a tail is also 50%, or 1 in 2. All right, now what does that probability mean, and how would we use it in the real world? Okay, so remember, we're saying if we flip a coin, there's a 1 in 2 chance that we would get ahead. And I'm just going to write capital H for denoting heads, right? And then tails will be T, all right? So if it is a 1 in 2 chance, then if anyone disagrees with the statements, let me know. If you don't understand it, give me a heads up in the chat. So what we're saying is for every 2 flips, one of them is bound to be a head. Okay, so for every 2 flips, one should be a head. And the same applies for tails. For every 2 flips, you expect one of them to be a tail. Now, if probability worked perfectly like that, then that means, let's say in the first flip, okay, I didn't get a head, I got a tail. In the second flip, right? Now, if this statement is true, for every 2 flips, and there's the first flip and there's the second flip, then this means that the second flip should return a head, right? But we know from experience that that doesn't always happen. You can get a tail again, all right? So it doesn't mean we're gonna get a head in the second flip. So you may ask, okay, so how do you even use the probability if this can actually violate it? If things like this in the real world can actually violate that? And the answer to that is basically probabilities do work, but they work for a very large number of trials. So in this example, I've only done 2 trials, but I could flip the coin again for the 3rd trial, 4th trial, etc. And the more trials I have, let's just say I go all the way up to the 10,000 trial. If I flip it 10,000 times, then that probability has value. What happens is, I don't think any of us has the time to actually flip a coin 10,000 times, but you can actually get a computer to simulate it. And basically what happens is, out of those 10,000 flips, half of them, in other words, around 5,000 or very close to 5,000, this means approximately 5,000 of them would be tails. Oh, sorry, yeah, 5,000 would be tails and 5,000 would be heads, roundabout. You wouldn't get the exact number, but it would be very, very close. You could get something like 4,980, which is still very close to 5,000. So that probability can be used. It's just that it's effective when you have a large number of trials. So let me just go to the chat and see if there's any questions. Does everyone understand that? Does that make sense to you? Do you have any questions about it? So that's how probabilities work. Great, thank you. I really appreciate the feedback. So probabilities do have value in that it works for a large number of experiments or trials, in other words, trials. And where could we see this in the real world? Well, one of the best or most common places you would see probabilities being used is a casino, right? Now, games, card games, roulette wheels, slot machines, all of them, they all have a probability of you winning, a probability of you losing. So obviously, when you lose, the casino wins. When you win, the casino loses, right? And casinos use these probabilities, and they can afford to use them because they do have a large number of trials almost on a daily basis. Now, what are those trials? Well, the first trial is basically me, right? I could be the first person, right? I go in this machine and I could spin it maybe 100 times. So just me alone, I could give them 100 trials. That's just me, one all the way to 100 trials. 100 trials. That's just me. But then that's just one customer. Imagine another customer comes in. Another customer comes in, and that customer would also add to these trials. If that customer also played the game, the same game that I'm playing, for another 100 times, then you've got another 100 trials. You've got 200 trials already. So that's just two customers. So you can imagine how many customers they have in a single day. So they could easily get these large number of trials. So probabilities for them really helps them, and it's very valuable for them. All right, so that's how it would be used in the real world. That's just casinos that I gave you as an example, but you can imagine, it's used in pretty much a lot of other institutions. Banks use it, and so on. All right, so let me go back to the chat and check if there are any questions. Okay, I'm hoping that makes sense to you and you kind of understand how these are used in the real world and how to actually make sense of them. All right, so now let's get back to the data, and what we're going to do in this session is we are actually going to work out the probabilities. Okay, we're going to determine what the values are. All right, so the first example that I'm going to take you through to explain probabilities is this data on the left in the table. Okay, so let me just clear this, and I'll explain that data. Now, this data that you have in the table is presented to you in a cross-tabulation table. All a cross-tabulation table is it basically looks at two variables and how they intersect or how they interact with each other. So the variable going down the rows, right, these are employer positions. So you could be a director, manager, or a junior position. So you could say employee positions. That's the one variable. And then in the columns, right, you can see we have mining and finance. So here it's industry sectors. So what you're looking at is a cross-tabulation of how employee positions interact with the industry sectors. Okay, those are the two variables. That's all a cross-tabulation table does. And how you interpret the numbers is, if you just look at this 21 in the first row in the first column, what it's telling you is that you have 21 directors in the mining sector. Then the 40 in the next column is telling you that you have 40 directors in the finance sector. And altogether, you have 21 plus 40 equals 61 directors in total. So you have 61 directors in total, right? 21 of them are in the mining, and the remaining 40 are in the finance sector. And you interpret it the same way for the next row for managers. You have 80 managers in the mining sector. You have 160 of them in the finance sector, and in total, if you add the 80 to the 160, you get the 240. Now let's look going down the rows. Okay, let's just look at this finance column here. Okay, here we're saying we have 40 directors in the finance sector. We have 160 managers in the finance sector, and then we have 240 junior positions in the finance sector. So altogether, if you add the 40, 160, and the 240, going down rows, you have a total of 440 employees in the finance sector. Okay, so I've included the totals for you in this table. If you're presented with a cross tabulation table, sometimes they won't give you the total. You just have to insert that. But it's pretty easy and it's pretty straightforward. Right. And then you have the grand total here, which I've listed here as in red. Just adding up all the numbers in your data. So 21 plus 40 plus 80 plus 160 plus 210 plus 240. If you add up all those numbers, you get a total of 751. So what it's telling you is there are 751 employees altogether. All right, that's your grand total. That's your grand total is 751. Okay, now we need those numbers to work with probabilities. Now let's say they ask us the first question. First question is, let me just clear this out so I can get some space. Right. They ask us for the probability of being a director. So what is the probability of being a director? That's the question. All right, before I go on, let me see if there are any questions. So far, all good. Okay. All right, so what you need to remember for the working on the probability of anything, okay, there's two things you need to know, right? Let's just give you the general understanding of probability. If you want the probability of a certain event, and I'm going to write it like this, P brackets of a certain event. And that event could be anything, okay? So if you want to know what is the chance of it, let's just say, what's the probability of getting a 1 when you roll a die? Okay, when you roll a single die, there are 6 numbers on the die, and you want to know what is the chance of you getting a 1. Well, to work that out, it's 1 over 6, right? And how you actually get that is you basically, the event that you're interested in is getting a 1. So it's the number of ways, I'm going to write it with the hashtag, it's the number of ways of getting a 1, right, divided by all possible outcomes. In general, this is how you would get the probability. Now, that's for the example of the die. Now, for in general, instead of writing getting a 1, what you would say it's the number of ways of the event occurring in general. Number of ways of the event occurring. Let's give you another example just to put things in perspective. Okay, you have 10 marbles, only 4 of them are red. So you have 4 marbles only. Sorry, what did I say? There's 10 marbles, only 4 of them are red. So what's the chance of getting a red marble? Could you put that in the chat for me? What do you think it is? What is the probability of getting a red marble if there are 4 red marbles and there are a total of 10 marbles? 4 red marbles, total of 10 marbles. So what's the chance of getting a red marble? Anyone? Come on. Just put it in the chat. Nobody wants to try? Okay. Okay. All right. So does everyone agree that the probability of getting a marble is 4 divided by 10? If you're uncertain about that, please let me know in the chat. Okay. And I applied the same principle I did here to get that probability. The number of ways of that event occurring in the numerator, that's basically the number of red marbles. And the denominator is all possible outcomes, which is basically 10 marbles. So that's how you get 4 out of 10, right? And we're going to apply the same methodology to get the probability of being a director. Let's clear this out. All right, so we applied the same method to get this probability, and I'm just going to abbreviate it as P of DIR, director, probability of being a director. So it's the number of directors. And if you look at our table, we have a total of 61 directors. So it's 61 over how many employees do we have in total? And that's the grand total of 751. And if you work this out, you'll get a percentage of 8.12%. Okay, so when you give your final answer for probabilities, you write it as a percent, 2 decimal places at least, all right, 8.12%. Let's check the chat. Any questions? Okay, all right. Okay, so that's the probability of being a director. All right, let's say the next question is, what's the probability of being in the finance sector? So the next question is, what is the probability of being in the finance sector? And I'll just write FIN for finance. Well, then to work this out, the numerator would be how many employees do we have in the finance sector? And that's 440. Okay, so that'll be 440 in the numerator, or the grand total, which is 751. So, and that gives you a probability of 58.59%. Yeah, I'm hoping everyone's just finding it too easy. That's why there's no questions. But if they are, please do let me know in the chat. I assume everything is good. All right. Okay, cool. So now we've got the probability of director and the probability of finance, of being in the finance sector. All right. Now we're going to do something called a joint probability. And all a joint probability is, just like the word joint, it's the probability of two events jointly occurring or occurring together. And what I mean by that is, let's look at the example. What is the question is, what is the probability of being a director, and instead of writing the word and, I'm going to use the mathematical formula, which is intersection, like that. It's like a upside down U. That's the same thing as and. So what's the probability of being a director and being in the finance sector? That's the question. Now here, you apply the same principle we started off with, okay? It's the number of ways of the event occurring divided by the total number of outcomes. So for the numerator, what we're looking at is, well, how many directors are in the finance sector? So that's what we mean by and, where they intersect. Okay, where does directors and finance intersect? So if you look at directors in the first row, okay, it intersects finance at the value 40. So that means we have 40 directors in the finance sector. So that's our numerator, 40. And it's still divided by the grand total, 751. That's the probability. If you work this out in the calculator, you get a value of 5.33%. Right, so that's a joint probability. All a joint probability is when you're working out the event, one event and another event occurring, right? And that's how you work it out. Okay, now the next one we're going to work out, and explain that in a second. No questions. All right, I'm going to clear the board on the top, because here we need to use a bit of a formula to get this answer. The question is, okay, what is the probability of being a director, or, okay, and write or here, and the mathematical symbol for or is this U, or in other words, union. What's the probability of being a director or being in the finance sector? So it's not the same as what we just did here. It's not the same. Here, this is an and, here it's or. So the question is, what is the probability of being a director or being in the finance sector? And here you would use a formula that's in your formula sheet, which you don't need to memorize, okay? You're given this formula in your formula sheet. It's probability of A union B equals probability of A plus probability of B minus the probability of A intersection B. Right, that's the formula you need to use. You don't need to memorize it, and you don't need to derive it. You just need to know how to apply it. And we're going to apply the same formula here. Only difference is instead of A, I have director, and for finance, that's going to replace the B in that formula. All right, that's what we're going to do. So all I need to do is, instead of writing A and B, I'm going to write director here, replace A, that would be director, intersection, and instead of B, it would be finance, and I'll have to replace this B here with finance. That's all I'm going to do. All right, I use the same formula, and I just replace the A and B with director and finance. And I have all these values. I already worked out probability of a director, there it is. Probability of being in the finance sector, it's here, I've worked that out. And the last term, this term here, I'll work that out as well, it's here. So I've got all these three values. All I need to do is plug them into this formula. I've put all these values into the formula, and I'll get my final answer, which is equal to 9.09%. That is the probability of being a director or being in the finance sector. All right, any questions? Good, let's check that. Okay, I'm just going to assume everything's okay. And if there are questions, please do let me know. All right, okay, now we are going to do one more formula for probability, and that is called the conditional probability, and I'll explain that in a second. Okay. Okay, and all right, let's say the question asks us for what is the, wait, sorry, I mean, this is not 9.09%. This should have been, if you plug all the values in, this should be 61.38%. 61.38%. Okay, sorry about that.
Sorry, sir.
Yes.
Hi, I have a question, but my chat isn't working.
Oh, okay.
So you know when it says probability of a director and finance,
Yes.
if you go back to your other screen, why did you use the 751 instead of the 440 underneath on the right?
I see what you mean. Okay,
Yeah.
so you don't use the 440 because that is used for conditional probability, and that's what we're going to do now. You always use the grand total, and you'll see why the because remember, you're looking at that event of directors and finance divided by the total number of outcomes. You're not just interested in directors being in only the finance sector. Does it make sense?
Oh, okay. Sorry, I understand. Okay.
Okay.
It does. Sorry. Thank you.
No worries. Good question. Very good question. But that 440 now will come in to what I'm going to do now. So it's a good question. All right. So now the question is, what is the probability of being a director given? And the mathematical symbol for given is this vertical line, given that you are in the finance sector. Okay, this is the question. I want you to work this out. Okay, to do this, you need to use the formula in your formula sheet, which is this: probability of A given B has occurred equals to the probability of A and B all over the probability of B. Okay, you need to use this formula. You don't need to memorize it. it's given to you. Right, I'm just going to circle it in green just because the board is quite busy and I want to draw your attention to this formula which we're going to use now. All right, so then we're going to work the probability out using this formula here. Now remember, instead of A and B, we have director and we have finance. Right, so we just use that same formula, but we replace the A with director and replace B with finance, and that becomes probability of director intersection or and finance. All I'm doing is I'm replacing the B with finance and replacing the A with director, all over probability of B, which is now finance. All right, now I'm going to, instead of just going straight to the percentages, let's do each one, right? So I'm going to clear this board, this part here. There. Okay, great. So now this numerator, let's just look at the top part. The probability of being a director and in the finance sector. We've already done that. There it is here. Okay, so the numerator is actually 40 over 751. So the numerator is 40 over 751. Right? We've done that already. That's the numerator. Now the denominator is this here. And that's the probability of being in the finance sector. And we've done that earlier. We did that earlier. Remember, it's how many people are in the finance sector, and that's 440 over 751. Now you've got a fraction over a fraction, right? So you can rearrange it. It becomes 40. The numerator remains unchanged, right? And it becomes divided by, right? Instead of writing the fraction, I'm saying divided by, which is 440 over 751. Now, rules of mathematics, when you've got a fraction over a fraction, what you can do is you can change this to a multiplication. Okay, you change this to a multiplication, and then you switch these two around. So that's what I'm going to do. So it'll be 440 in the denominator and 751 in the numerator. So now what happens is these two cancel, and you're left with 40 over 440. This, to your question, Jessica, why we didn't divide by 440 before is because here is where you actually divide by the 440. Okay, because of that. When it's a conditional distribution, then you would only look at the total in that denominator. And if you work this out, now you'll get a probability that the final value should be 9.09%. 9.09%. That's your final answer. Okay, so conditional probabilities, you use this formula here. When you need to work out the probabilities of something or something occurring, right, or the union of two events, A union B, then you use this formula here. And that's basically the two formulas that you need to apply for probabilities. For everything else, you do it with the methods that I showed you. Okay. Any questions before I move on? Everyone good? If I can get a thumbs up or question if anyone is uncertain about anything. Thanks, Nadi.
Instead of doing the fractions within the fraction, can you just like total it before you do the? Can you just like get the sum answers and then put it in the fraction instead?
Yeah. So let me see.
Yeah. Just wondering if it's gonna work.
So in other words, you could just put the percent over the percent.
Yeah, the percent of the percent.
Yes, you could do that. The only reason I did it this way is just to show you why you get the 440 now and didn't.
Okay.
But you could perfectly just take the percentage and divide them by each other, if that makes it easier for you, which I'm sure it does. So in other words, let me just write it out so everyone else understands, but it's a good question. So we're going to, I'm going to remove this and this. So previously, earlier in the session, we have out the probability of being in the finance sector, which is equal to 58.59%. Right, we worked that out earlier. Now, what we're saying is, instead of doing that whole fraction method that I did, just go straight to what you have in the numerator first, which is here. We've done that already. It is already a percentage. So that numerator is 5.33%. 5.3, that's not a negative. We divide by this, 58.59%. So we just replace by percentages. You can do that, and you'll get the same answer that we've got here. That both are perfectly fine. Hey, good question. And it's moving around. All good? Everyone happy? Think everyone understands it? Okay. I'm going to, perfect. Thanks for the feedback, everyone. Okay, now we're going to move to counting techniques. Okay, so I'm going to create a new whiteboard for this. Right. So counting techniques, all right, what exactly are they? Well, it's just ways of actually determining how many possible outcomes you can have, right? So let's give you an example, right? Let's say, I'm assuming everyone is familiar with like a podium or any sort of event like the Olympics or some competition. So we have a podium. I'll do my best to draw it. Yeah, sorry. As accurate as I can. Yeah. That's position 1, that's position 2, and then you get position 3 here. So if you came a third, you're here. You came a first, you're there, and you came a second, you're there. All right. So that's your podium. Okay, your podium is there in any sport. Okay. Now you got, let's say you got 7 people competing, and instead of writing their names, I'm going to make it a bit easier and just write the letters. So A is person 1, and we've got person 2, which is B, person 3, 4, 7. I think that's 7 people. 1, 2, 3, 4, 5, 6, 7. Okay, we've got 7 people competing. Now the question is, how many ways? Right? Can the podium be filled? And how many ways can we actually fill this podium? So what they're asking is, okay, let's consider it. One way is if person A came out first, person B came out third, person C came out second. That's one way. Right? Another way is if this is switched around. Instead of B being here, you would have C here, and B could be second. That's another way. That's 2. Now, instead of us doing it the way I'm doing it, like fiddling around, playing around with all these different combinations, it's going to take me too long to figure that out, and it's very easy for me to forget one, right, to miss out one. So there is a mathematical way to do this, right, and that's where permutations and combinations come in, right? The first question you want to ask yourself is, now, look at this instance here. We've got person A being 1, B being 2, and C being 3, right? So that's one way, okay? So person A came out first, person B came out second, person C came out third. That's one way. Second way, okay, number 2, so let me write it separately. Okay, so with one split, yeah, person A, B, and C. The second way is if person A still came out first, but C came out second and B came out third. Now, these 2 arrangements, they're the same people. They are the same people, but their arrangement is different, and their arrangement counts. Okay, they're considered different because they occupy the podium in different ways. So the question is, how many ways can the podium be filled? So this is one way, this is two. So what we're saying is the order matters, and that's very important. The order matters. When order matters, then we use permutations. Okay, then we use permutations. And I know this may be like some complicated, this word, but I'll show you why it's important when you do the calculation. So in order to determine the number of ways we can fill this podium, okay, what you need to do is you're going to apply the permutation function in your calculator. And in your calculator, you'll see that above the, what button is it? The multiplication button. If you look at above the multiplication button, you'll see something like this, NPR. That's the permutation function. That's what the P stands for, permutation. Means. And what the N is, the N is how many are in your set altogether. Basically, what you're asking is how many competitors do we have in total? Well, we have 7 competitors, so that's what your N is. Your N is 7, right? That's in our example, N is 7. The R is basically telling your calculator how many do you want to select from that 7. Well, the question is how many ways can we fill this podium? And the podium only has 3 positions, so we're selecting 3 from 7. So that's what your R is. Your R is 3. So all we need to do is we need to tell the calculator to work this out for N equals 7 and R equals 3. And how we're going to do that is you're going to follow what I'm going to direct you in your calculator. All right. So everyone has their calculator out. It's all switched on and ready. Okay, what you're going to do is you're going to type 7 first. Type 7. Then you're going to press Shift. Okay. Then you're going to press that multiplication button because that's where the NPR is. You press the multiplication button. All right. And then you are going to press 3 because that's what your R is. So on your calculator, you should see something like this. You should see 7P3. Once you see that, just press equals to. Press equals to and tell me what number you get in the chat. Enter the number that you get in the chat. Anyone that gets an error, you can let me know, but I want you to tell me what you got in the chat so I know that you're doing it correctly. Oh, you've done it. Anyone else? Anyone not getting 210? Now is the time to speak up. Because you need to get comfortable working these things out. Okay, so if you work this out, you've got 210, and that's the answer. There's 210 ways of filling that podium. All good? I'm assuming no one has any issues because no one's saying anything. Thanks, Nadi. Thank you. All right. Okay. So when the order matters, we use permutations. Right. So now let's say the question is phrased a bit differently. Let me clear this board. Okay, so now question is how many top 3 groups are there? Okay, so the question is how many top 3 groups are there? We're done with this question. We got an answer of 210. Right. The second question is, now let's just look at one instance. We got A, B, C. Okay, so A came at first, B came at second, C came at third. Let's just say we now had C who came at second and B who came at third. If you look at it, it's the same group. We don't care about the position. Okay, so the second question here, these two instances, they counted as one group. In other words, the order does not matter. For the second question, that's what we're saying. The order doesn't matter. Not matter. So in this case, you would use combinations. So you are going to use the NCR function in your calculator, and that's above the division button in your calculator. So you're going to do the same method we did before, but you're going to use the NCR button. So how are you going to do that? We still have 7 competitors, so you're going to type 7 in your calculator. First type 7, then you will press Shift, then you will press the division button. That's where the NCR is. And then we're still selecting 3 groups. Question wants 3 groups, so that's your R. And you're going to press 3, and then you're going to hit equals to. And you can write what number you get in the chat. So you can have an idea if you're doing it correctly. What number do you get? Anyone? No one tried it? Very good. Yeah, that's it. 35. Your answer is 35. So the answer to the second question is 35. Very good. All right, it's very important that you understand when to use permutations and when you use combinations. Permutations, you use it when the order matters. Combinations, you use it when the order does not matter. All right. Now let's combine what we did earlier, which is probabilities, and we're going to combine counting techniques, like what we just did now. And I'll show you how you use them together with a question. Okay, start. Okay, this is the last question we'll do for this session this evening. So thanks for sticking around. Almost done. All right, that's good enough. All right, so just like before, we still got our 7 competitors, which is A, B, C, D, E, F, and G. All right, now the question is, question is, what is the probability of C, person C, person D, and person E, right, filling the podium? That's the question, right? So we want to know, what is the probability of C, D, and E filling the podium? So just like what we did earlier in the session, remember we defined a probability of any event, right, is the number of ways that event can occur divided by all possible outcomes. That's how we're gonna answer this question. So the numerator is basically what you're asking us is how many ways, right, can C, D, and E fill the podium? So if I had to try and write it up, right, so one instance is we have C being first, D being second, E being third. And another instance is C being first, E being second, D being third. And I can keep going on. Maybe E comes out first, C comes out second, and D comes out third. Now, I don't want to do this manually, okay, because I'm going to be prone to error. So we need to figure a way to work out just the numerator. So how many ways can we rearrange or arrange these three people? And you can see here the order does matter, because this is one instance. Even though they're the same people, the order matters, because this is another instance, this is another instance, etc. So now what we're doing is we're trying to figure out how many ways can we arrange three people out of these three people, all right? And how you would do that is you would use permutations. You would use N, P, R, but your N is 3 because that's how many people you have in total to fill the podium. 3, and your R is you're still selecting 3 from them. You're just trying to figure out how many ways you can arrange these 3. So that's your numerator. Your numerator for this problem is 3, P, 3. If you work that out, you get 6. Okay, but you don't need it now. All we need to know is that's the numerator. And the denominator is what we already worked out. We already worked this out earlier. It's all possible outcomes is basically how many ways can you fill this podium? That was the first question we answered. And that was 210. And how we got that is, well, we have 7 people in total. So we're still doing permutations, and we're selecting 3 because that's the only way we can fill the podiums with 3 people. Now, if you put this in your calculator with a fraction and you worked it out as a percent, you'll get 2.86%. 2.86%. And that's how you work it. So that's how you combine counting techniques with probabilities. Right. And that is all I want to cover. Let me just check if there's questions. Oh, good. I'm hoping it is. If anything's unclear, please let me know. But that's it. That's it for this evening. That's all I wanted to cover for this session. So you've done probabilities. Okay, you've done the rules of probabilities, how to apply the addition rule. And the addition rule is basically that probability of A union B formula. How to work with conditional probabilities, how to work with joint probabilities, how to interpret a cross-tabulation table, and permutations and combinations. And that's it for me. Are there questions, anyone? Everyone understood the content? I'm just assuming the silence is a yes, but please let me know otherwise. Everyone good? Thanks, Jessica. All right. All right. If there aren't any questions, then that's it for this evening, and we will chat again soon. Thanks for joining, everyone. Really appreciate it. I will make the recording available by tomorrow. Have a good evening.